All right, Foundations and Pre-Cal 10. Here we go with a short for the arithmetic series portion of the bonus of section 2. So remember that in an arithmetic sequence, we were looking at a list of terms with a common difference, determining how many were in the list, so on and so forth. And when we get to a series, we are now looking at the sum of an entire series. So we're taking a series like this, and we are now plunking in these plus signs, and we are adding the entire series together. So what we get is we get two different equations, and we can use them depending on the information we have given. If we're given the last number in a list, we can use this equation because we need a plus L. If we're not giving the last number in the list, but we're giving enough other information, we'll use this one. So we'll see both of them at play here. So the first one is find the sum of the positive integers from 1 to 50. So that means, well, okay, n is 50. And I know that my first term is 1, and I know in this case that my last term is 50. So in this case, I can use the first equation. The sum of the first 50 positive integers is equal to 50 over 2 times 1 plus 51. Watch the full lesson for a good connection to Gauss in this video. So 25 times, that's a 50, times 51. So the sum of the first 50 digits comes back and gives us 1,275. So when we have the necessary information, this is pretty straightforward. So what happens if we don't? So now if we look at this one, we're looking for the sum of the first 25 terms, but we don't know what that last term is. But what do we know? We know n is 25. We know a is 11, we know n is 25, and we know d because the difference between these is 4. So we know d is 4. So we have enough information to use the equation on the left. So we know that the sum of 25 terms is equal to 25 over 2 times 2 times 11 plus 25 minus 1 times 4. And then we just work this through, a bit of algebra, a bit of arithmetic. 25 over 2, now we have 22 plus 24 times 4. So the sum of 25 terms is 12.5. It's okay to go to a decimal. And then we get 22 plus 24 times 4. Now 24 times 4 is 96, so we get 22 plus 96, which then gives us 12.5 times 22 plus 96. 118, and then we multiply the 118 by the 12.5, and we get that the sum of those 25 terms, even though we don't know the last one, is 1,475. So sometimes we don't need the last number in order to get it. So what about this one? Well, here we are. We got the last number. Okay, we got L, we got A. What's my common difference? 3. Okay, we got D. Great. But what's missing? Oh no, we don't know N. Well, here's the good news. We can find N by using our arithmetic sequence equation. So remember we did this one in the last video, because in this one, we know A, we know D, we know Tn, we know the nth term is 100. We just don't know what term that is. So we're going to use this first. We're going to say, okay, well, Tn equals A plus n minus 1 times D. Tn is 100, the nth term. We don't know what n is. A is 7, and then we leave this n minus 1 and then times our d 3. So now let's subtract 7 from both sides. We get 93 equals 3 times n minus 1. If we divide both sides by 3, we get 31 equals n minus 1, and then it's just add 1 to both sides, and we get n. N equals 32. Once we have n, then the good news is we know the first term, we know the last term. We can now use s of 32 terms is equal to 32 over 2 times 7 plus 100. So the sum of those 32 terms is 16 times 107. And then we just do that calculation. The sum of 32 terms is 1,712. So if we need to find n first, we can always backtrack to our sequence equation, and we can solve for n. And then we can go from there because we have the pertinent information. So another one, same scenario. We have our L, we have our A. Now we can't use this equation either because we still don't know n, right? So we need n first. So again, our Tn is equal to a plus n minus 1 times d, and in this case my d is 4. 5 plus 4 is 9, plus 4 is 13. So Tn, my nth term, is 137. I get 5 plus n minus 1 times 4. I'll subtract 5 from both sides, and I get 132 equals 4 times n minus 1. Divide both sides by 4. Let's throw that in just in case. 132 divided by 4 gives me 33. So 33 equals n minus 1. So that means in this case, n is 34. So again, we've solved for our n, and now we can use our sum equation. So sum of 34 terms is equal to 34 over 2 times a plus l. And I get the sum of 34 terms is equal to 17 times 142. And then 17 times 142 is 2,414. So this stuff is really all about completing a puzzle. Sometimes pieces are missing, and you got to put some pieces in before the picture becomes more clear. So a lot of practice here. Remember, this is bonus for grade 10 because we look at it again in grade 12. But if you're flying ahead and you want a bit of a challenge, give it a try. All right, see you next time.